Hello everybody and welcome back. So here is another question on orthogonality. So now we should find the orthogonal value P to remove the cross product term, to find the transformation equation and identify the central conic in the equation. So since we have just two terms here, x and y, so the matrix we are going to form will be 2 by 2. Okay, so we're going to have a new matrix. You can name it A or any letter of your choice, and that is going to be x and y. So we multiply by x, we have x squared, by y xy, by x xy, by y squared. So this is the matrix we are going to form and the coefficient of x squared in this equation is 0 because we have no x squared term there. So that will be 0. For xy, we have just one xy because if we check, the coefficient of xy here is 1. So you will have just one xy. And we have two of them here, so we have to split it for them. So since we have 1 here, 1 divided by 2 is 1 over 2. So we are going to have 1 over 2 here, and we have 1 over 2 here. The coefficient of y squared equally is 0. So we don't have any y square here again. So this is the matrix we are going to find its characteristic polynomial, and from there we get the eigenvalue and eigenvector. So but we can use the shortcut lambda square minus trace lambda plus determinant. So the trace of this matrix is equal to 0 because the trace will be the sum of these diagonal elements, and the two of them is 0 as 0, so the trace will be 0. But the determinant, it will be this times this. 0 times 0 is 0, minus half times half is 1 over 4. So the determinant is minus 1 over 4. So our characteristic equation will become lambda square minus the trace, which is 0, okay, minus 0 lambda, then plus the determinant, which is minus 1 over 4. So lambda square minus 1 over 4 equal 0. So that's the characteristic equation. So this is what we are going to solve to get the lambda. So easily we can say that lambda square equal 1 over 4, and lambda will be equal to the square root of 1 over 4. Okay, so lambda will be equal to plus or minus 1 over 2. So don't forget to put plus or minus, because the square root of a number is another number that when you multiply it by itself, you get the number under that square root. So the square root of 1 over 4 is not only plus 1 over 2. Minus 1 over 2 is also square root, because minus 1 over 2 times minus 1 over 2 will give you 1 over 4. The same way plus 1 over 2 multiplied by plus 1 over 2 will give you 1 over 4. So the answer could either be plus 1 over 2 or minus 1 over 2. So your lambda can be plus 1 over 2 or minus 1 over 2. Alright. So that's our eigenvalue. Now we have to get our eigenvector. So I'm going to come back here using the equation A minus lambda I times the eigenvector to give 0. We're going to say when you put that A here minus lambda I, lambda times the identity matrix will give you lambda 0 0 lambda. So when you subtract from here, we have 0 minus lambda. Okay, we have 1 over 2 0 minus lambda times the eigenvector, which is I can use x and y as well, but normally we use v1 and v2, but you can use x and y as well. So 0 0. So from here we can solve and get x and y. Now let me simplify this further. If you simplify, you can have minus lambda 1 over 2 minus lambda x y, then 0 0. Now you say when lambda, because we have two values now for our lambda, either lambda is plus 1 over 2 or lambda is minus 1 over 2. So when lambda equal plus 1 over 2, you have in bracket of minus 1 over 2, 1 over 2, 1 over 2 minus 1 over 2. Okay, you have to put lambda in that equation, then times xy equal 0 0. From here we can have this row times this column. That will be minus half x plus half y equal 0, and we have half x minus half y equal 0. So the two equations are the same. You can pick the first equation, minus 1 over 2x equal minus 1 over 2y. So that means x equal y. Okay, and from here you are going to take the coefficient of x for y and of y for x. So the coefficient of y and x is 1 1. So definitely the answer will be 1 1. So that is for when lambda equal to 1 over 2. So when lambda is equal to minus 1 over 2, we have to find the eigenvector for that case as well. So how are we going to start? Let's start from here. So when lambda equal minus 1 over 2, we put that here. We have minus 1 over 2 will give you 1 over 2, 1 over 2, 1 over 2, minus 1 over 2 will give you 1 over 2. Okay, then we have xy equal 0 0. From here we can have half x, that is you multiply this row by this column, plus half y equals 0. Okay, and we have half x for the second one plus half y equal 0. So the two equations are the same as well. Half x will be equal to minus half y from equation 1 or any of the other So from here we have x equal minus y, because if you cancel the 5% by half, this is what you have. So from here x and y, okay, will become, so the coefficient of y will be the value of x, that's minus 1, and coefficient of x will be the value of y, and that's 1. So x becomes minus 1 and y becomes 1. So these are the eigenvectors that we need to get. Now don't forget, the next step after we've gotten the eigenvector is to normalize. So we are going to normalize each of these eigenvector. Now to normalize the first one, we are going to have the normalized value will be 1 over square root of 1 square plus 1 square. Okay, and the other one will be 1 over square root of 1 square plus 1 square. So this is going to give us 1 over square root of 2, and this is going to give us 1 over square root of 2. Also for this one, to normalize, we have 1 over minus 1 over square root of minus 1 square plus 1 square. Okay, that's going to give us minus 1 over square root of 2, and this is going to give us minus 1 over plus 1, because the second one is plus 1. So it's only the first one that is minus 1. So for the second one we have 1 over square root of minus 1 square plus 1 square, which is going to give us 1 over square root of 2, because minus 1 square is 1, then 1 square 2 is 1, so when you add them you have 2. So that's how to normalize. Now your P, okay, the matrix P you want to find would be, okay, the matrix you will get when you put all these normalized value column wise, that is column by column. So for the first vector here, this is the normalized value you get, and for the last one, this is the normalized value. For the second vector as well, you get this first and this second. So you're going to put them column wise. Now to put them column wise, you put the first one first, which is 1 over square root of 2, and the second one 1 over square root of 2. Then you put this 1 2 like that, 1 minus 1 over square root of 2, and also 1 over square root of 2. So don't forget, the next thing to do now is to find the transpose. The transpose of this matrix will be the matrix you get when you switch the rows, okay, of this P matrix to column. So this is the first rule and this is the second rule. So when I switch this first row to first column here, I will have 1 over square root of 2 and minus 1 over square root of 2. The second row to second column, we have 1 over square root of 2 and 1 over square root of 2. So this is the transpose. Now to get the matrix they are asking you to find, the value, that is going to be the new matrix, say for instance B, which will be the product of the transpose of P times the A, then times the P itself. So we have B equal 1 over square root of 2, 1 over square root of 2, minus 1 over square root of 2, 1 over square root of 2, times the A. Of course, the A was gotten to be 0 half half 0. So you multiply. Then times the P. The P is half half minus half, okay? So that's 1 over square root of 2, 1 over square root of 2, minus 1 over square root of 2, 1 over square root of 2. So we're going to multiply these three matrices together. So we have this row times this column. So that's going to be this times 0 is 0 and this times this is going to give us, don't forget, yeah, so this times this will give us 1 over square root of 2 times 1 over 2, okay, and this one times this one will give us 1 over square root of 2 times 1 over 2, then plus this times this, that's going to give us 0. So this times this, okay, this row times this column as well, so this times this will give us 0, then plus this times this, as 1 over square root of 2 times 1 over 2. Then we say this times this as well, so that's minus 1 over square root of 2 times 1 over 2, then plus this times this, which is going to give us 0. Alright, then times 1 over square root of 2, 1 over square root of 2 minus 1 over square root of 2, 1 over square root of 2. So we are going to have B to be equal to 1 over 2 root 2, 1 over 2 root 2, and we have 1 over 2 root 2 minus 1 over 2 root 2 times 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. Okay, then we have B to be equal to this times this. So this times this will give us 1 over 4, okay, and this times this will give us plus this times this, that's going to give us 1 over 4 as well. Also we have this times this, so this is going to give us minus 1 over 4, then plus 1 over 4, because what we are doing basically is that we are using this first row to multiply the first column to get this, and this one too to get to multiply this to get this. So the same thing here, we have 1 over 4, then times minus 1 over 4. Okay, so we have minus 1 over 4 minus, alright, so minus 1 over 4. There's a problem somewhere, because anyway, let's continue. Okay, no problem, actually there's no problem anyway. So we are going to have B equal 1 over 4 plus 1 over 4, that's going to give us 2 over 4. Okay, this is going to give us 0, this is going to give us 0, and this is going to give us minus 2 over 4. If you simplify it further, you have 1 over 2, 0, 0, minus 1 over 2. Alright, so that's how to remove the cross product term from that equation. And that's not the only question. We're asked to find the orthogonal value P, to remove the cross product, and to find the transformation equation, and then identify the central conic. So to do that, from here, you will see that the equation is just xy equal to, and from there, you can say that the coefficient of x squared here will now be what? 1 over 2x squared. Then that of y squared here, because if you compare it, it will be x squared, xy, xy, y squared. So only we have removed this cross product now. So we have just x squared and y squared. So the coefficient of x squared now is half. Then minus half y squared equal to. Don't forget, our initial equation 2 is what? Was equal to. So this will be equal to. Now to find the central conic will be, now let us divide the two equations. Let us divide the both sides by 2. So that will be 1 over 2 x squared divided by 2 minus 1 over 2 divided by 2 y squared equal 2 divided by 2. So we have 1 over 2 divided by 2 x squared, it's like that. Okay, minus 1 over 2 divided by 2 y squared equal 1. So all we have here will be times 1 over 2 x squared minus 1 over 2 times 1 over 2 y squared equal 1. So we have 1 over 4 x squared minus 1 over 4 y squared equal 1. So we have x squared over 4 minus y squared over 4 equal 1. So these are the central conic you are asked to find. Don't forget, in conic section, this is how we leave our equations. So that's all for this video. Thanks for watching. So, and there's nothing much, nothing less. So but let's say, for instance, we have this equation x squared plus 3xy plus 3xz plus 3y squared equal maybe 42. I asked the same question, just that this equation is different, it's changed now to this equation. So the only thing you need to do here now is to form another matrix. I'm just showing you what to do, not that I'm doing it. So what you would do is that, because we have x, we have y, and we have z, so we have 3 unknown now. So that's going to be a square matrix with 3 sides, and that's 3 by 3. So all you just do will be x, 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 y, 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 z, z, z. Now I start multiplying by x, y, z from the left to the right. So x here, we have x squared times y times z times x times y times z times x times y times z. Then you now put the coefficients one by one. For x squared, the coefficient is 1. So, and we have 1 of x squared here, just put it. For xy, we are having 2 of them. Okay, and we have this to be xy. The coefficient of xy is 3, so you split it to 2 for them. So for this one we have 3 over 2, this one too we have 3 over 2. Don't forget, it's for these two xy. Then for xz is just 1, or is 2 xz, so you still split it for them. So we have 3 over 2 here too, and we have 3 over 2 here too. Now for y squared, that's 3, so we have y squared to be 3. There's nothing like yz in the equation, so it means that the coefficients will be 0. It's like 0 yz like that, so we have to put 0 here, and yz still 0. Then z squared, no z squared as well, so 0. So this is the 3 by 3 matrix. We find it, that you're going to find its eigenvector. After you find the eigenvector, you have to normalize. After you normalize, you find the transpose. You find the matrix. After you find the matrix, you now find the transpose. After you find the transpose, you now find the new matrix. which is the product of the transpose, times the age you get, which is this A here, then times times the P. Alright, so that's how you get your matrix. So I can just practice some questions based on that. So I'm not going to do anything like that. And that's how we're going to end the topic. Yeah, that's how we're going to end the topic for that. We're going to end the topic. So thanks for watching once again.